Welcome, ladies and gentlemen. We're looking at last night's homework, was page 781, and here's a problem where I'm trying to write a fraction with an infinitely long repeating decimal. And we're trying to write it as a fraction. Did I say fraction? Right as a yeah, decimal. Yeah, we're good. All right, whatever. So first of all, let me write this as a sum, and we'll see what we get here. So I'm going to write this as 0.2 plus, well, actually, yeah, we'll do that. Plus 63 over 100. Nope, 1,000, wouldn't it be? Yeah, that's the thousandths place. Plus 63 over, and now this is a good question. How many zeros is this going to have?
6.
Is it?
5.
Because it's only 2 more spaces that have been added, right? So it's only adding 2 digits, so this should only add 2 zeros. This was 3 zeros because I had that extra spot representing it. And then this would be plus 63 over 1, 2, 3, 4, 5, 6, 7 zeros. And it goes on forever. Now, I can't find a geometric pattern for this. However, if I bracket this and this, I could find the sum of this infinite list and then just add 0.2 to it at the end. And that would be oh so great. So a sub 1 is going to be 63 thousandths. R, also related to that how many zeros question. What's R going to equal? 1 over 100, since we're adding just 2 zeros per, or 2 spaces, 2 digits per fraction. So lots of little potential areas to make errors. Areas. That's what I could call them. So let's find the sum of these infinitely many terms. I believe the formula is a sub 1 over 1 minus r. It's a really nice, simple formula. Find the sum of infinite many things. I wish other things that took forever could be done so easily. So let's see, 63 over 1,000. Let's see, if I call 100 hundo, what would I call 1,000? Thouso? It's not as good. Thousy? Thou? Yeah. Yeah, I guess that would work. So I get this stack-o-frac situation going on here. So that's 63 over thou. Yeah, I need like a 2-syllable thing going on, I think is what I need. Multiplied by the reciprocal of that would be hundo over 99. And now I can cancel out some stuff. These 2 zeros cancel out with these 2 zeros. 63 and 99, those are very divisible by 3 looking, if I ever saw anything. 3 goes into 63 21 times, and into 99 33 times. It looks like I can divide even more.
711.
Yeah, divide by 3, divide by 3. Yeah. So this fraction is equal to 7 over 10 times 11. 1/10s. Sure, I don't know. So that's what I get. However, notice that is not my answer. Wah, wah, wah. Because I have to add this remaining little dude up here. Duder. I could call that 2/10 if we wanted. Plus 7 1/10. I'd have to multiply this by what, like 11, I guess?
Yeah.
So 22 plus 7 is 29 1/10s. Nintendos. There we are. So there it is. So it's not impossible. Lots of potential little spots for error, but good stuff. I like it. I like it a lot. So other questions? Other preguntas? Did we have to do some on these lists, I think? Yeah, no, maybe. Any of these any good? What about these square root ones? Did we have to? We didn't have those? Would you know how to do those, though? Let's do this 39. This 39 looks like a boss. Uh-oh, I just hit an undo button. Oh well.
Should I tag this onto my work?
You could just follow along, Zeb. You could just follow along. Here we are. Paste. This one's probably going to be less about infinite sequences and more about, do we know how to simplify fractions and radicals? Am I right, my psychic friend in the back? I think so. So let's see. A sub 1 is 8. R would be the, let's see, the ratio of second term to first term or third term to second term. I'll call that negative 4 roots of 3 over 8. So that looks like negative root 3 over 2. Oh, this is a thing of beauty. So I can find the sum of the first infinitely many terms. 8 over 1 minus root 3 over 2. Right?
Minus negative root 3 over 2.
Oh, thank you. Good catch. Man. So 1 plus root 3 over 2. 8 over, that'd be 2 plus root 3 over 2. Let me make this vinculum the master vinculum. Master vinculum could possibly be the name of some evil Sith Jedi in the new Star Wars movies that might be coming out, made by Disney. I don't know. I could see that being a good name.
Vinculum.
Darth Vinculum. Seriously, how great would that be? So let's see. How do I deal with this ugly fraction? It's like an upside down snowman going here.
Exact fraction. 16 over 2. On top.
How did I do to what?
Make it 16 over 2 on top.
Instead of 8, make it 16 over 2. Insane.
Oh, yeah. I guess. Yeah, that could work.
The
That could work.
denominator of the denominator is
My
a
friend. Nope.
factor of
It's
the...
a numerator. Numerator.
The denominator of my denominator is my factor.
I would multiply by the reciprocal of the denominator here. That's what I would do. I could think of that 8 as 8 over 1, but yeah, thinking about it as 16 over 2. That's not bad thinking. That could work. So let's see, and then I'd end up with 16 over 2 plus the square root of 3.
So you
No.
just have to say that.
Wrong.
Yeah, which I would never leave it this way, because there's a...
Multiply it by the conjugate over conjugate.
Oh, what? Man, with the callback, I can't just multiply by root 3 over root 3. I got to multiply by the conjugate, because there's a binomial down there. That's the only way I'll get this figured out. So this is equal to 16 times that. I'd have to distribute. So that's going to be 32 minus 16 roots of 3 over. And then when I multiply these, I could use the difference of squares pattern, right? A plus b times a minus b is equal to a squared minus b squared. And that's the beauty of this pattern, is each of the terms within it are squared. So it's like designed for killing square roots. It just kills them all over the place. It's really good stuff.
It wasn't designed for it. It was designed for it.
Yeah, true. Well, it probably wasn't designed for that reason. It was probably just discovered at some point. But yeah, anyways, we've got some good stuff going on here. So 2 squared is 4, minus root 3 squared is 3, and
That's 1.
that is 1. So that is the sum of the infinitely many terms in this list, which I would like to point out are alternating in sign. And since my R value has an absolute value greater than 1, nope.
No, it doesn't.
No, it does not. Because the square root of 3 is 1.73 something. And
It's
No,
less
that would
than
be
the
greater than
square
1.
root of 4, which is
well,
2.
dividing by 2.
So it's still less than 1.
Yeah,
It has to be at least the square root of 4.
classic. So yeah, good stuff. The sum would have been just infinite in size if the absolute value of r was greater than 1. Question, comment?
How would you know whether it was positive or negative?
It would
Is it because the first term
Ooh.
is positive and then all the terms below it are smaller, so then it
probably.
would stay positive?
Yeah, that would be a good hunch. That's what I was going to say. If r was greater than 1, then it would have been alternating signs, and the sum would have been alternating itself.
It wouldn't have existed for 2 reasons.
Yeah, it would have, because, the sum of the infinite list, it would have been, basically, one end would have been, every other term would have been approaching positive infinity, and the other terms would have been approaching negative infinity, and it would just have been so disagreeing with itself that no sum would be able to be found, no infinite sum, that is. What is infinity plus negative infinity, though?
Infinity.
I guess 0, depending on the size of the infinity.
There is no size
Well, like-
of infinity.
N minus n, where n approaches infinity, would be 0, but n squared minus n, where n is approaching infinity, that wouldn't quite work out. So anyways, let's end this little homework video, and bye, Internet.